Materials Connexton has been interested in and been sourcing sustainable materials probably for the last 12 years. We're not specifically a sustainable materials company, but in finding innovative material solutions, we found that within the last 5 years, there's been increased interest by our clients to find materials that are not only innovative, attractive, cost-effective, solve their performance needs, but also now sustainable. The idea of cradle to grave, of course, is that during the production of a product, you have the initial extraction, whether it's from oil or whether it's from the ground or whether you grow it from a tree. And then it needs to be synthesized or somehow processed into a raw material that's usable by a company. That raw material then needs to go and get manufactured into a product. Once that product has then been manufactured, it's then sold and used, and at the end of its life, typically, we landfill it. So it goes from cradle, it's an initial sort of coming out of the ground or from a tree, all the way through to grave, which is a landfill. Cradle to cradle is differentiated from cradle to grave by being a loop rather than a linear process. The idea, instead of going from cradle to grave, where you go along basically a linear process from extraction all the way through to landfill, cradle to cradle takes that and instead of going into landfill, recycles the material in some way so that it can again be used as a raw material for more production. At Materials Connexton, we spend a lot of time sourcing, finding new sustainable materials. Two of my favorites for this year have been two very different materials. One is a concrete, the other one is a packaging material. And I think the two highlight the differences that are possible between two different sustainable materials. Let's take the cement to start with. Developed in the UK, it's called carbon negative cement. If one takes the whole concept of carbon footprint, construction is one of our largest carbon footprints. We spend a lot of energy, we put a lot of carbon dioxide into the air in constructing new buildings. It's one of the largest on the planet. One of the largest parts of construction is concrete. For every ton of concrete that is produced, one produces around a ton of carbon dioxide. So for a building that's 100,000 tons, you're putting out 100,000 tons of carbon dioxide into the air just during the construction. It's been the same for the last 100 years because we've always been using a material called Portland cement. It's the standard concrete that's used in all construction. These scientists in the UK developed an alternative to that. So by simple changes in chemistry, changing from carbonates to silicates in the formulation, and in doing so reducing the temperature required to create the concrete, because there's an awful lot of heat used in creating the original cement before it's made into concrete. They've taken it down from a ton of carbon dioxide per ton of cement down to actually sucking up 50 kilograms of carbon dioxide per ton of cement. So instead of giving out an awful lot, you're actually taking it away from the atmosphere. So imagine if we're able to create all new construction using this new type of cement. Suddenly the carbon footprint of new construction is just reduced significantly, such that you could probably meet your country's carbon footprint requirements simply by just changing this material. So you don't see any difference in the material, doesn't look sustainable, doesn't look any different, but by this changing chemistry, we're able to effect huge changes in the carbon footprint of new construction. So shows a great potential. But that's something that you probably won't ever see. You'll hear about it, but it's not, hopefully won't create any changes in our day-to-day lives. And that, I think, is one of the most effective sort of solutions for sustainability. As a consumer, I don't want to reduce my quality of living. I'd like not to. So solutions that allow us to maintain our quality of living with no real change in performance while still reducing carbon footprint, I think are to be lauded. That is different slightly from some of the more, is my other example, which is a material called Eco-Cradle. This is a packaging material also used as insulation that is very much the sort of standard but very interesting sustainable material. It is a mushroom-based packaging material. So instead of using expanded polystyrene, the stuff they make packing chips out of, and the corn of the pink stuff that your new computer comes in, that's expanded polystyrene. This is a mushroom alternative. They grow it in the dark in 7 days in factories up in upstate New York. Requires virtually no energy, no light, and grows very quickly and sustainable and is compostable. Currently being used by Steelcase, an office furniture company, and also Dell is prototyping it as a material to package all their computers in. Looks very sustainable, it's a great story, looks wonderful, but is sort of the other side from the unseen sustainability story, where this has garnered a huge amount of interest because it just looks so different. It looks very sort of granola in its appearance. It's a great story, but it shows you the difference in what sustainability can do, whether it's a high-profile, granola-looking packaging material that everyone loves and everyone sees, or an unknown, unseen construction material, but that is also improving our standard of living in terms of sustainability.